In this video, I'm going to go through the solutions to the sample exam number 3. So for our first question, we've got this function, and this person, Gina, has been analyzing this function and created this number line with our pluses and minuses and trying to figure out what does the first derivative test tell us about our original function. So when we see this number line here, what we're seeing is that the information about f that we're being given is that when f prime is positive, f prime is going up. And that when f prime is 0, f is flat. When f prime is negative, f prime is going down. And then when f prime is 0, f is flat. And then when f prime is positive, f is going back up again. So what we see is that f has a maximum value, a local maximum, at x equals 0, and a local minimum at x equals 2. So that's what we would be able to conclude. So f has a local max at x equals 0, and f has a local min at x equals 2. For the next one, we're talking about an initial value problem. So remember, in these kinds of problems, we're given the derivative, we're given f prime, and we're given a value of f, and we're asked to find a formula for f. So what we need to do is take the antiderivative of our f prime. So the antiderivative of 3x squared is x cubed plus a constant. And so that's my f of x. And then when they tell me that f of 2 equals 5, then that's going to tell me that f of 2, which is 2 cubed plus that mysterious constant, is equal to 5. So 8 plus the constant equals 5, so the constant equals minus 3. So putting those two pieces of information together tells me that my function is x cubed plus negative 3, or in other words, x cubed minus 3. So that would be my formula for f. Next up, we've given this function. We're told that it's continuous at this value of c. I should actually say 3. I'll fix that for you. And f double prime of 3 is equal to negative 4, and we want to know which of the following statements has to be true. Notice that they didn't tell us that this is a critical point, so this is a little bit of a tricky question. So all we know is that f double prime of 3 is negative 4, so all that tells me is that my function is concave down at x equals 3. It does not tell me that I have a local minimum, which is what you might think from the second derivative test. The second derivative test only applies when we're talking about a critical point. Now this one, and actually the next two, talk about absolute minimums and absolute maximums. So first of all, let's think about this notation here. So when we say negative 4 to 3 with an open parentheses on the negative 4 and a closed bracket around the 3, that means that my function is going to start over here at the point negative 4 comma 16, and it's going to be my regular x squared shape, and then it's going to go up here to a filled in dot at the point 3 comma 9. So when we're talking about absolute minimum, remember that means the lowest possible value of my function over this entire interval, and that's going to happen here, and that's going to be at the point 0 comma 0. For the next one though, absolute maximum, again I'll recreate my picture here. So open circle at negative 4 comma 16, closed circle at 3 comma 9. The absolute maximum for this function doesn't exist. It's certainly not here at 3 comma 9 because there are higher y values over here close to the point negative 4 comma 16. But the maximum doesn't occur at negative 4 because the function on this interval doesn't ever actually get to that point, negative 4 comma 16. So in this case, the function does not have an absolute maximum. It's getting bigger and bigger and bigger as I get closer to that point, negative 4 comma 16, but I never actually hit that point, which means I never actually get to a maximum value. So this has no absolute maximum value on this interval. And if you remember, the theorem that we had said that a function must achieve both an absolute maximum and an absolute minimum on a closed interval. And this is not a closed interval because of that round parentheses around my negative 4. Okay, this one's talking about sigma notation. So what we can do here is, because it's multiple choice, we can just actually figure out what this sigma notation represents. So for A, my sum starts at I equals 3 and ends at I equals 11, and the formula that I'm plugging into is just I. So this is going to be 3 plus 4 plus 5 plus 6 all the way up to 11, and that's not right because my sum skips over the even numbers, so that's not correct. This sum here again starts at 3 and ends at 11, and the formula I'm plugging into is I plus 2. So what that means is I'm looking at 3 plus 2 plus 4 plus 2 plus 5 plus 2, right? Each of those numbers between 3 and 11 I'm plugging into that formula until eventually I end up with 11 plus 2. And that's definitely not right, because that's 5 plus 6 plus 7 going all the way up to 13. That's not even close to what we want. This next one, I starts at 1 and ends at 5, but again my formula is I plus 2. So that's going to be 1 plus 2 plus 2 plus 2 plus 3 plus 2 plus 4 plus 2 plus 5 plus 2. But again, that's not right, because that's 3 plus 4 plus 5 plus 6 plus 7. And again, not the sum that we want. So process of elimination, we know it's got to be D, but let's just check it out. This is going to be 2 times 1 plus 1 plus 2 times 2 plus 1 plus 2 times 3 plus 1 plus 2 times 4 plus 1 plus 2 times 5 plus 1. And that is 3 plus 5 plus 7 plus 9 plus 11. So that's what we want. Now for this next few questions, we've got a graph of f prime. And again, I've mentioned this in class. With these problems, it's really important to understand that this is not the graph of f. I'm asking you questions about the function f, but the graphical information that we have is about the function f prime. So if they're asking about f of x being decreasing, we have to translate that statement, f of x decreasing, into the language of f prime. So if f of x is decreasing, what we know is that means that f prime of x is negative. So the part of this graph that we're looking at is from here all the way through these negative y values over to here. So that's going to be from x equals -3 to x equals +2. Or in other words, in interval notation, -3 to 2. Same graph, this time we're listing the critical points for f. Well, f of x has a critical point. When we translate that into the language of f prime, that means that f prime of x is either equal to 0 or f prime of x is undefined. Now, this graph is never undefined. I don't see any asymptotes or holes or anything like that. So if we're looking at f prime of x equaling 0, that's going to happen 2 times, here and here. So that's going to be at x equals -3 and x equals 2. Next up, where does f of x have an inflection point? Well, what does inflection point mean? F of x has an inflection point. Well, it's easiest to translate that into the language of the f double prime. So we'll do that first. This means that f double prime of x changes from positive to negative, or from negative to positive. Right, in other words, my function f is changing concavity, is changing from concave up to concave down, or vice versa. So how do I translate that into the language of f prime? Well, if f double prime is changing from positive to negative, f prime is going to be changing from increasing to decreasing. Again, or vice versa. So, or from decreasing to increasing. So where does that happen? Well, that happens here. That's where my graph f prime changes from going down to going up, and it happens again here. That's where my graph f prime changes from going up to going down. So the answer to my question would be x equals 0 and x equals 4, because those are the points at which that happens. Okay, so this problem is a graph of h, right? So the function h is the graph that we see. So when we're asking for absolute minimum, this is the graph that we're going to be looking at. Absolute minimum is pretty easy to spot. It's just the lowest possible y value, which in this case is right here at x equals the letter u. So that would be my answer to this one. Local maximum, on the other hand, is not the biggest y value that we ever see, but the y values that are bigger than any other nearby y values. So in this case, that's going to be at p, at r, and at t, and remember, not b. Endpoints, for technical reasons, don't count as local maximum values. So just P, R, and T here. And then finally, on which intervals is h of x decreasing? Again, we can just read this off the graph. So where is h going down? That's going to be from P to Q. And then it's going to be from R to S. Again, I'm using interval notation here. And then it's going to be from T to U, and that's it. So a little bit easier to answer those kinds of questions when the actual function that we're asking about is the graph that we see. Okay, now we've got an optimization problem. So this says, of all rectangles with perimeter 40 inches, what are the dimensions of one with the greatest area? Okay, so drawing a little rectangle here, let's label our sides. We've got L and W for our length and our width. So they're telling us that the perimeter is 40 inches. So that's going to be our constraint. That's going to be the limitation on the values that L and W can take on. And that constraint is going to be 2L plus 2W, that's our formula for perimeter, is equal to 40. And then now they're also asking us to maximize area. So that's going to be the objective function. We want to maximize A, which is equal to LW. And again, our thought process here is we know how to find a maximum value. We're going to take the derivative and set it equal to 0 and test the value and see if it's a max or a min. But the problem is this formula for area has too many variables in it. So how do we fix that problem? We're going to fix that problem by using the constraint. We're going to use this formula 2L plus 2W equals 40. We're going to use that equation to eliminate one of the variables. And it doesn't really matter which one we eliminate. I'll just go ahead and eliminate L. So I'll write this as 2L equals 40 minus 2W. Divide both sides by 2, I get 20 minus W. So now I fix my area formula and write it as 20 minus W times W. I want to take a derivative, so I want to make this as easy looking as I can. So now my A prime is going to be 20 minus 2W. That's never going to be undefined. I set it equal to 0 and solve. That's going to give me W equals 10. Now it's tempting to just stop at this point and say, oh, okay, the width is 10, got it. But I need to test this and make sure that it actually is a max. So I'm going to use my first derivative test. So A prime, my critical value is at 10. So I'm going to plug in something bigger than 10, something less than 10. So A prime of 5, that's going to be 20 minus 2 times 5. Remember, I'm plugging into my A prime formula, not my A formula. So that's plus over here. And then I'll try A prime of 20. That's going to be 20 minus 2 times 20. That's negative 20, which is negative. And that really is a max by my first derivative test. So I found the max. Now did I answer the question? Well, the question asked for the dimensions. I figured out the width, but I didn't figure out the length. So the dimensions are the width equals 10, and the units in this problem are inches. And the length, well, I know that's 20 minus W, so that's 20 minus 10, which is also 10 inches. So that would be the answer to my question. All right, another slightly more complicated optimization problem, but similar kind of approach. We want to design a box-shaped package. The width of the box must equal twice the length, and the total volume must be 1,000 cubic centimeters, and we want to know what are the dimensions that minimize the surface area. So I'm giving you the formula for the volume, I'm giving you the formula for the surface area. Now, we want to minimize the surface area, which means the surface area is my objective. I want to minimize this one. S equals 2LW plus 2LH plus 2WH. That's my objective. Now I've got some constraints. I've actually got 2 constraints in this problem. What I know is that, here's my length, here's my width, here's my height. I know that the width must be equal to twice the length. So that tells me width is equal to twice the length. And I also know that the volume must be 1,000 cubic centimeters. So the volume, which is LWH, is equal to 1,000. So this lets me eliminate the W. So I've got L times 2L times H equals 1,000. Now that formula has 2 L's in it and 1 H. So it's going to be easier to solve that for H. So that's going to give me 1,000 over 2L squared, also known as 500 over L squared. So now over in my surface area formula, I can eliminate W by replacing it with 2L. And I can eliminate H by replacing it by 500 over L squared. So 2 times 2L times 500 over L squared. So now my surface area formula is entirely in terms of L. Now I'm going to be able to take derivatives and figure out my max and min. So this is going to be cleaning up this formula a little bit, 1,000 over L. This is going to be 2,000 over L. So 4L squared plus 3,000 over L. And again, I'm about to take a derivative, so I'm going to go ahead and use some negative exponents there, make it a little bit easier to do that. Okay, so I take my derivative. So my S prime is going to be 8L minus 3,000 times L to the minus 2. And that's undefined when L is 0, but the length of this box can't be 0, right? So this is 8L minus 3,000 over L squared. I can't divide by 0, so I can't plug in L equals 0, but the length of the box being 0, that doesn't make any sense in this problem, so that can't be a critical point. So I'm going to add that fraction to both sides. Multiply both sides by L squared. That gives me 8L cubed equals 3,000. L cubed equals, that's going to work out to be 375. So now L is going to be the cube root of 375, which again, I throw that on my calculator. And that's going to be approximately 7.2. So I think that might be my minimum, right? Remember, I'm trying to minimize my surface area. This time I'm going to test it with a second derivative test, just to be different. So I'm going to say S double prime, that's going to be 8. The derivative of 8L is 8. That's going to give me plus 6,000 times L to the minus 3. And I'm going to plug 7.2 into that. So on my calculator, I'm typing 8 plus 6,000 times 7.2 to the negative 3. And that gives me, it helps if I type it in correctly. Let's try that again. Raised to the negative 3. I'm going to get about 24.07. And that is positive. So that means I do, in fact, have a min just like I wanted. So I'm almost done with the problem. This is a longer one. So I'm almost done with the problem. The only thing now I have to do is to answer the question. And again, this question asks for the dimensions, which means I'm not just able to give the value of L, I need to give the value of the other variables as well. So the dimensions are, well, I know L, 7.2. W is 2L, so that's 2 times 7.2, which is 14.4. And then H is 500 divided by L squared. And again, hop over to the calculator. That's going to be about 9.65. So those would be my, and these are all centimeters, so those would be my dimensions of my box. So a little bit longer problem, but same basic process, right? So we've got our constraints, we've got our objective, we eliminate all but one of the variables, we take a derivative, and then once we're at the point where we're taking derivatives and testing maxes and mins, that's where it's probably going to feel a lot more comfortable, right? Because you'll know what you're doing there. Okay, so these last couple of problems involve areas. So we want to evaluate this area using geometric principles, not the fundamental theorem of calculus. Remember, the fundamental theorem is not covered on this exam. It will be covered on the final. So what we're doing instead of that is we're getting a graph of this function. And the good news is that y equals 3x plus 4, that's just a line, so that's not hard to draw. Y equals 3x plus 4. And so if I'm going from x equals 2 to x equals 5, this shape that I have here is a trapezoid. And we typically don't remember the formula for the area of a trapezoid, so what I'm going to do instead is chop this into a rectangle and triangle, because I do know those formulas, hopefully. So this distance is 3, so the base of my rectangle is 3, that's also the base of my triangle is also 3. So now I just need to figure out these heights, and then I can figure out my area. Well, these points are on my graph, and this point has x-coordinate 2, and this point has x-coordinate 5. So 3 times 2 plus 4, that's 10. So this is 2 comma 10. And 3 times 5 plus 4, that's 19. So this is 5 comma 19. So the height of the point 2 comma 10 is 10. And then it's 9 more units from 10 up to 19. So the height of my triangle is 9. So the area of the rectangle is base times height. 3 times 10 is 30. And the area of my triangle is 1/2 base times height. 1/2 times 3 times 9. That's 13.5. Add those together, I get 43.5 as my total area. All right, last one. So now we want to evaluate a Riemann sum using 4 subintervals and the right-hand endpoint of each subintervals. And as we've talked about in class, I recommend that you make a chart for organizing your information. So for each interval, in this case we've got 4, so 1, 2, 3, and 4. We want to figure out the delta x. We want to figure out the base of our rectangle, which is the delta x. We want to figure out the xi star. In other words, that's the number that we're actually going to plug into our function. And then the f of xi star, that's the actual height of my rectangle. And then the area of my rectangle is just going to be base times height. So this column's giving me my base, and this column's giving me my height. Now to figure all this stuff out, I'm going to draw a little number line. So my b value is 11, my a value is 3, and my n is 4. So delta x is b minus a divided by n. In this case, that's 11 minus 3 divided by 4. That works out to be 2. So on my number line, I'm starting at 3, I'm ending at 11. And at each step, I'm going up by 2. So 3 plus 2 is 5, 5 plus 2 is 7, 7 plus 2 is 9, and then 9 plus 2, and that is 4 subintervals. Now they're telling me to use the delta x is 2 at each time, and they're telling me to use the right-hand endpoint of each subinterval, which means I'm going to use between 3 and 5, I'm going to pick the 5. Between 5 and 7, I'm going to pick the 7. Between 7 and 9, I'm going to pick the 9. Between 9 and 11, I'm picking the 11. So I'm picking the one that's on the right. Now, if this problem were phrased a little bit differently, and if it said left-hand endpoint, I would have picked the left-hand endpoint. If it had said pick the midpoint, I would have averaged the two numbers to find the number halfway in between. So whatever point they tell you to pick, that's the one you want to pick. But in this case, my xi stars are 5, 7, 9, and 11. And now I'm plugging those into my function. My function is x squared plus 1, so this is going to be 5 squared plus 1. This is going to be 7 squared plus 1, square root of 9 squared plus 1, square root of 11 squared plus 1. So this is going to be, again, I'm hopping over my calculator, about 5.1. 7 squared plus 1, that's going to be about 7.07. 9 squared plus 1, that's square root of 82, which is about 9.06. And 11 squared plus 1, that's going to be about 11.06. But those are the heights, right? So big common mistake, you do all this work and then you make this silly mistake at the end, you forget to multiply base times height to figure out the area. So this is going to be 2 times 5.1, which is going to be 10.2. 2 times 7.07, which is going to be 14.14. 2 times 9.06, which is going to be 18.12. And 2 times 11.06, which is going to be 21.12. And then those are all the areas of the individual rectangles. Now we add those all up. So 10.2 plus 14 plus 1.14. Oh, and I'm just realizing they told me to go 3 decimal places, so I messed that up. All right, let's go back. So square root of 26, so that was 5.099, right? Be good and follow instructions. Do as I say, not as I do. So 7.071, that's my 3rd decimal place. 9.055, that's what that was. Get rid of that 6. And then 11.06, oh, sorry, square root of 122 is 11.045. Oh, so that's actually wrong anyway. 0.045, there we go. Okay, so now, get rid of all these, and we'll fix it. See, this happens, right? You're working through a problem, and you get part of the way through, and you realize you messed something up, and you go back and you fix it. So I am not immune from that either. All right, so 2 times 5.099, 2 times 7.071, 2 times 9.055, and then 2 times 11.045. Okay, so 2 times 5.099 is 10.198. 2 times 7.071 is 14.142. 2 times 9.055 is 18.11. 2 times 11.045 is 22.09. All right, now we add all those up. So 10.198 plus 14.142 plus 18.11 plus 22.09 all gives us our grand total of 64.54. And that would be our final answer. So long story short on this one, as long as you're showing your work, you're making a chart, keeping yourself organized, showing me where all your numbers come from. If you make a little flub like I did and forget the number of decimal places, that's going to be worth a very small number of points. The main thing that I'm going to be looking for is the process, knowing how to figure out delta x, how to figure out the base and the height and all that good stuff. So sorry for the bump in the road on that one, but we're done with the solutions to the sample exam. Hope this helped. Bye.